All right, so right now we're going to be working on section 10.3 part B, and we're going to talk about the arc length in parametric form. So if you guys remember, let me write this down here first, arc length in parametric form. So in rectangular form, we had this, s equal to the integral from a to b of the square root of 1 plus f prime of x quantity squared dx. So that's the way it was before in rectangular form. So I'll kind of put that right here. This is rectangular form. Rectangular meaning normal, usually the way we write stuff, you know, y equals mx plus b, that type of stuff. What I'm going to do is I'm going to assume that x is f of t, and y equals to g of t. So I'm going to make it parametric by introducing a parameter. So by following the basic steps that we're going to do here, I'm going to notice s is equal to the integral from a to b of the radical of 1 plus. Now, the derivative f prime of x, another way we can write it is dy dx, which is, you know, just normal. I'm not doing anything special. But once I do that, I notice that we know how to take the parametric, the derivative of a parametric equation. So this is going to be dy dt over dx dt quantity squared dx, because that's what dy dx is in parametric form. Now I'm going to go ahead and distribute that power, so it's going to give me an integral from a to b of the square root of 1 plus dy dt squared over dx dt squared dx. Now, I'm going to want to combine 1 with that fraction, okay? So these things right here, I'm going to want to put them together. So I'm going to write integral from a to b of, now I have to get a little creative with the number 1. I'm going to write it as dx dt quantity squared over dx dt quantity squared. That way they have the same denominator as the other fraction, which is dy dt quantity squared over dx dt quantity squared dx. Now, I'm going to put those two fractions together. I know I'm taking step by step here. Some people may actually be able to do this a lot faster just in their heads, which is fine. That's what I would do, but I'm trying to show all the steps, so let's show all the steps. So dx dt squared plus dy dt squared divided by dx dt squared dx. All right, great. I notice that the denominator can be taken out of the radical. Since it is a square, I can take it out. So this is the integral from a to b of the square root of dx over dt squared plus dy over dt squared times, now if we take out dx dt squared from the denominator, we end up with 1 over dx dt. And then again times dx. Well, let's just keep simplifying, just doing a little bit of algebra here. This square root stays the same, dx dt quantity squared plus dy dt quantity squared times, now 1 over dx dt is the same as dt over dx times dx. Now you'll be able to cancel out these dx's and end up getting the formula that we're looking for. So integral from a to b of the square root of dx dt squared plus dy dt squared dt. So this is one form of the parametric or arc length in parametric form. If you want to write it a different way, you can. Remember that dx dt is just the derivative of x, so you can do the following if you want to. You can write f prime of t squared plus g prime of t squared, okay? Or some people would rather just write s equal to the integral from a to b of x prime of t squared plus y prime of t squared dt. I forgot to put the dt up there. So that's how you find your arc length in parametric form. Now, all these three are acceptable in using. It just depends what you prefer to see. Okay? So completely up to you, your choice.